Okay. So, and again, your points, these questions are very good ones. And the way to really answer them is to try it. Okay, so let's talk about this, about naming variables. Okay, so, and I think I have this on a slide too. This is slide 24. Now we talked about some data types already. String, this is a string data type. Oops. This Mike, right? This is a string. This 3, quantity 1 at this point will be a string, a int type, integer type. This quantity 2 will be an int type. List price will be a float. Okay, but these aren't really variables. You know, if you're used to other programming languages where you think about it's creating an object, most object-oriented programs, you think about this as it's creating a little object that's floating around in random access memory, if it's R, for example, because that's how R works, that has the value of 3 in this case. And this would be a little object, an int type class object that's floating around in memory that has a value of 5. But Python doesn't work like that. It is object oriented, but what actually happens is when it runs this, it assigns an address in your memory, which is not in RAM, I don't believe, that is called quantity 1. Okay, and it stores 3 at that address. Okay, so it doesn't really know what the type is until it actually executes. So it's subtly different. But anyway, we talked about, so these are strings, these are ints, these are real numbers. So let's go here to the slide, which is a little, I'm sorry, to the script, which is a little different from this. And I think I jazzed it up a little bit here. Okay, so first name is Mike, right? And then I'm going to run this all at once. This is a executable script, even though I don't have the shebang line up there. And I should, because that's what I tell people to do, but I didn't. So it's going to run here. Let's run it and then we'll look at it. Okay, so if I run this, prints all this stuff out. First name is Mike, quantity 1 is 3, quantity 2 is 5. List price is this. First name now is Joel, quantity 1 now is 10. Quantity 1 changes again to 5. Quantity 1 changes again to 15. Okay, well, so what's going on there? Well, and that's not it. This is it over here. Well, I'm recreating these variables. Int. Okay, and this is going to be confusing because it's still confusing to me, but int data types are immutable. An int variable is immutable, which means you cannot change the value of it. You might say, well, Jeff, didn't you just do that? Here, quantity 1 is 3, and then down here, quantity 1 is 10. Well, not really, because when I called this line here, it takes a little piece of memory and it names it quantity 1, and it associates this value with the address name in memory of quantity 1. Now, when you're looking at this, it looks like, well, I just created a variable called quantity 1, but you didn't. You just named, you reserved a name in memory and you associate this value. When you come down, and it's int at this point. When you come down here, what actually happens is it cannot change this. It cannot change the value that is stored in this memory location. So what it actually does is it destroys this, it destroys this memory location and makes an entirely new one, picks a different spot in memory, and it names it the same thing, quantity 1, with the value of 10. Now you think about that, you say, what are you talking about? Well, some variables, most of the primitive variables like int and float are immutable, which means you can't change the value of that location in memory to a different location. But you have data structures, and we'll look at them in a couple of days, where you assemble all of these variables into a list or into a matrix or into a set. You have dictionaries, you have sets, you have tuples, and you have and lists. And what they are, they're different data structures, some of which are mutable and some of which aren't. And, at this point, me saying this is probably not being helpful, but you'll appreciate it later. You'll appreciate it later. But anyway, these are not changeable. So the simple explanation of this, of course, is that we're changing the values of whatever these are. They're 3, 5, 1999. And we're printing out little explanations and then the variable itself. We could do, if we wanted to do this one, let's see if I can do this on the fly. We'll say the list price, and I always mess these up. I'm going to change this to an F statement. So I'll say list price is, and we can get rid of the comma, and we can get rid of that quote, and we can put the ending quote here, and we're going to have to put this, since this is a real variable, we're going to have to put this in braces. These are called braces. And we want the spacing to be right. So that looks good to me, but I'm wrong 50% of the time. So let's see if this works. So I say save, and I run it, and it worked. Okay, it was this line. Which line was it? It was this line here. List price is $19.99. So I just changed that one to an F statement. And some of these are spaced a little weird, but so what's the point there? Well, generally, you should do it one way or the other. And in the long run, you'll be better off using F statements because they're inherently easier. You have fewer commas, and instead of having all of the arguments separated by commas, you don't have to do that. You don't have to have the number of strings, different strings. Everything's one string. And the rule is, if it's a real variable, you put it in that string, but you bracket it with the braces. And so if it's a complicated print statement, this is a lot easier. And you can also use, I believe, and let's see if this works, escape characters. Now, escape characters do special things within a string. An escape character is always preceded by the backslash. Let's do a couple of these. Okay, so this is the tab escape character, which works inside a string. When it's interpreting the value of this string or any string, it comes up here to the backspace, and it says, because this is a backslash, I know that the character that immediately follows it is going to tell me to do something associated with formatting. It doesn't interpret this or print it literally. It says, I'm going to take a break here, and I'm going to say, okay, well, the T means tab. So it's going to tab this over one unit. So let's see if this works, and I hope it does. So I'll say file save, and I'll run it. And did it tab list prices? I'm not sure if it did or not. It doesn't look like it. Let's try that again. How embarrassing. Let's say tab. This is why you always want to try things out before you show it in front of a live audience. Okay, file save. Run. Yeah. I put two tabs. The one tab didn't change anything because this by default is a tab and this by default and this by. But when I put two tabs, notice what it did. Okay, so let's try something else. Let's do this. Let's say we'll use a different escape character. We'll use N, which means new line. Okay, and we'll save this. And this should cause it to continue the print statement, but on the following line. Okay, so now I run this. Right, so list price is, and it gets that \n, and that tells the compiler, the computer, to whatever follows goes on the next line. And if there's anything else in that string, right, that would also, I could say, on the next line. Okay, notice I don't have to fool, even though this is an additional string that I'm adding. It's all one string. And you can put all this stuff together, right? So I say save, run. And here is the \n right here. And it just, whatever's after it all goes on the next line. Okay, so what else can we say about this? It can't really be 1:13 p.m., is it? Good grief. Okay. Let's move it along quickly, a little more quickly. Okay, so, you know, as an aside, I enjoy teaching Python. And sometimes that's not good. Okay, so naming variables, right? There are some rules. Variable name must begin with a letter or an underscore, nothing else. Can't start it with a number, a space, a special character. It's got to be a letter or an underscore. You can't have spaces. You can't have any punctuation except for an underscore. Numbers can't start with numbers. You can't use a keyword as a variable name or to create a function. These are all reserved words in Python that do something special. And if you try to create a variable with this name or a function with this name, it won't work. Notice true and false. Where's false? Here it is. True and false. These are reserved words, which mean exactly what you think they do. False is a 0 or it's not true. True means 1, means it is true. They begin with capital letters. Okay, that's not common to all programming languages, but it's common here. You can use small f, ALSE, any way you want. You just can't use uppercase F, ALSE as a variable name because it's reserved. Okay. Generally, again, this is a stylistic thing. Variable, first of all, you want to make variable names meaningful. You know, monthly investment, monthly underscore investment. Somebody looks at that, they know what value is. You don't want to use abbreviations or weirdly named variables that only you know what they are. That's crazy. You want them to be descriptive. Generally, I do this. I use the underscore notation. You can't, I don't believe you cannot begin a variable name with an uppercase letter. So you have to, this is camel case, where every subsequent word is capitalized. Okay. Some people do this, but not too many. Most people do this and use lowercase. Why use an uppercase letter somewhere? Somewhere along the line, somebody's going to forget about it, mistype it in. So I just find the underscore to be less error prone. Okay, so it's got to start with lowercase. Use one of these two techniques. Don't use the name of built-in functions. Okay,